Hello guys, I'm Jack and today we will study Chapter 4, Technique of Integration and Chapter 5, Infinite Series. So first, what is integration? Integration is the opposite of differentiation. Differentiations find how something changed, but integration finds the total or accumulated amount. Integration is like adding many small pieces together. In real life, if you know your speed while driving, integration can help you find the total distance while driving. So next, what is infinite series? Infinite series means number that can be continued forever. Example, 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 and so on is mean the pattern continue infinitely. So now we will learn the first integration technique, which is U substitution method. This method is used when an integral contains a function inside another function. It helps simplify the complicated expressions. For an
Now, let's try an example. We need to evaluate the integral from 0 to 1 x cos f squared dx. So the solution is we need to choose the u first. We choose x squared as the u, and then we sub the u into the x squared, so become cos u du. Then du equals to 2x dx. After we differentiate it, and we throw the 2 in front to the x dx. So it will, then we throw the 2 in front to the du. So become x dx equals to 1 over 2 du. Step 3, change the limit. When x equals to 0, u equals to 0 square. So the answer is 0 lah. When x equals to 1, u equals to 1 square, then is equals to 1 the answer. After that, we substitute the value into the formula. So 1, 0, then we substitute this formula. Then we substitute this equation into the formula. So become 1 over 2 integral from 0 to 1 cos u du. And the last step, we integrate it. So become 1 over 2 sine u. Then we do the integration. So become the final answer is 1 over 2 sine 1. So now, what is integration by parts? Integration by parts is used when two different types of function are multiplied together, like polynomial times exponential or polynomial times trigonometric. So the formula for the integration by parts is uv minus integral v du. Now, let's solve an example. Integral from 0 to 1 x ln x plus 1 dx. So first step, we need to let u become the ln x plus 1, and then we differentiate it will become 1 over x plus 1. This one can refer to the formula booklet. So for the dv is x, because here, so it's x dx, and after we integral it will become x squared over 2. Step 2, we need to apply the formula, which is the previous slide, is this, the uv minus integral v du. So after we apply the formula, it will look like this. And then we simplify this thing. So will become x minus 1 plus 1 over x plus 1. And the last step, we integrate the whole formula. This one, the 1 over 2 ln 2 is come from this here. And we just sub this equation into here. So it will look, so for the last step, we need to integrate the whole formula. This one, 1 over 2 over ln 2 is come from here. This, after we integrate this, it will look like this. And this one is come from here. Then we just sub the 1 into the x minus the 0 sub into the x. So the final will look 1 over 4.
Next, I will show how some common mathematical functions can be expressed as infinite series. In mathematics, many complicated functions can be rewritten as an infinite sum of simpler polynomial terms. These expansions are known as Maclaurin or Taylor series. They help simplify calculation, especially when dealing with integration. First, let us look at the exponential function. The exponential function e power to x can be expressed as an infinite series as 1 plus x squared over x factorial plus, is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x power to 4 over 4 factorial, and so on. This means the exponential function can be rewritten as an infinite sum of power n x divided by factorial values. Now, let us look at a logarithmic function. The logarithmic function ln 1 plus x can be expressed as ln 1 plus x equals to x minus x squared over 2. So this is the comparison analysis for the integration techniques and infinite series. So you guys just can go through it lah. I will show a real-world example where infinite series and integration are used together. Integration and infinite series are widely used in engineering, especially in heat transfer problem. For example, engineers design cooling system for laptop, engines, building, and semiconductor chip. Heat flow can be described using the heat equation. Partial T over partial small letter t is equal to k times partial square capital T over partial x squared, where the capital T represent the temperature, the small letter t represent the time, x is the position, and k is the thermal constant. Engineers often express temperature using infinite series. Each term in the series represents parts of the temperature pattern. All in all, integration helps engineers calculate coefficients and extract important information from data, while infinite series help build complete mathematical models and allow accurate prediction over time. Together, these methods help engineers solve complex real-world problems. That's all for now. Thank you.